You are about to experience a fascinating journey through the clean rooms of the semiconductor industry. See integrated circuits in the making at one of Global Foundries' chip factories. Let our experts walk you through the nanocosmos of the atom. A world that normally remains hidden from our eyes. In the beginning is the circuit diagram. At design centers around the globe, experts collaborate to design circuit diagrams, sophisticated integrated circuits like microprocessors, high graphic processors, and wireless communications ICs. The next step is manufacturing. The disk substrates for the microchips are made from quartz sand and are called silicon wafers. To make these wafers, a huge monocrystal is drawn from purified silicon melt. The result is a perfect silicon lattice into which the transistors will later be fitted. However, impurities pose a threat to these flawless silicon crystals. Our Global Foundries manufacturers must therefore take extensive precautions every time they enter our dust-free clean rooms. The result? Our wafers are fabricated in an environment that is more than 100,000 times cleaner than an operating theater. Completely free of dust, the silicon discs arrive at the clean room. Here, 25 wafers are packed into each hermetically sealed container and sent off on a journey that will take them through hundreds of manufacturing steps. Photolithographic techniques transfer the circuit structures to the wafers, rather like slide projection. The key to this whole process is a solid mastery of switches are generated on each wafer, tiny transistors. From the photolithographic stage, wafers move on to the ion implantation, where the electrical properties of the transistors will be specified. Here, the engineers make good use of one of silicon's most important properties. Silicon is a semiconductor, which means that its conductivity can change via a high precision emplacement of so-called dopant atoms. First, dopant atoms are injected into the silicon structures. These atoms then distribute randomly in the silicon lattice. At high temperatures, the doping atoms become flexible and take on a fixed position in the atomic structure. The complexity of manufacturing tiny transistors requires a clean room as big as 2 soccer pitches. While our people monitor the complex processes, automated manufacturing itself always takes place within hermetically sealed production lines. Copper dominates the next process step. The finest interconnect wires link up billions of separate transistors to form integrated circuits.